In this example, we're given the graph of a sine function, and we want to come up with the formula that would produce this graph. So being that we're given it's a sine function, I'm going to kind of look at a few points that kind of correspond with a sine graph. So as we know, the sine graph starts like in the middle, typically goes up first, comes back down, and then finishes up back in the middle. So I'm kind of indicating these 2 points, just focused on those because that's going to help me saying, well, it starts at 0 and then it's going to end over here at 2 pi. So with our sine graph, it looks to me like the period has not changed. So I know that I'm not going to have some multiple attached in here with the x, okay? Because the period didn't change, I would be looking for a multiple here if the period had changed. All right, next thing I like to do when I'm doing these is go ahead and draw in what we would refer to as the midline. All right, so the midline should cut, yeah, it's not perfect, but it should cut right through the middle of our graph, meaning that half of the graph is above this and half of the graph is below it. Now that has changed that on the normal sine graph, you start at the origin, go up, and then come back down. But in this case, it looks like that midline has been moved up 2 units to cut right through it. So what that's going to tell me is that I'm going to add a plus 2 at the end, that everything in this sine graph has been shifted up 2 units. From there, now that I have my midline drawn in, I can kind of look at my amplitude. So from the midline to the highest point on this graph, it looks like we go from 2 up to 3, so that's only 1 unit difference here. Or from 2 down to the lowest point, it looks like we go from 2 to 1. Again, that's only 1 unit difference in here. That sort of tells us that the amplitude remains at 1, so there's going to be a 1 sitting out in front here. We don't always have to write that 1 out in front. The only other thing to double check on this is, do we have some sort of phase shift going on? Has the entire graph been picked up and moved to the right or to the left? So in this case, because we start at the y-axis at an x value of 0, I would say that this graph has not been picked up and moved to the left or to the right. Now, technically, you could go ahead and say, well, it's been moved to the left 2 units, and it actually starts over here, or at 2 pi units. But that's just complicating things more than we need to. Let's focus on the points that I indicated, saying we start here, we go up, we come back down, we end right in the middle again. So I'm going to say we don't have any phase shift going on in this particular graph. So I'm not going to include a plus or minus in the middle here. Maybe we could put a plus 0 if you wanted to. But in this case, this hasn't been moved around too drastically. I'm just going to go ahead this and say this is the graph of sine of x plus 2. And that should take care of our amplitude, no phase shift, no change in the amplitude. Really, the only thing that happened in this one is everything got picked up and moved up 2 units and set back down. That's why we're including the plus 2 at the end to indicate that change. All right, hope this helps out as you're working on going from graphs to functions that will give you those graphs. Good luck.